Hello.
How's it
Uh,
going?
hello, Safwan. Welcome.
Thank you.
So we decided to maybe work on the thing that I'm working on currently a little bit. It's the workspace space suspension with delayed termination. So the short explanation of the background context is currently workspaces, there's like a configurable time at which they will hard terminate, which means the entire Kubernetes namespace is reclaimed, deleted, all attached volumes, any data they had on the attached volumes, all gone. We had complaints from initial adopter customers that was effective to data loss because even though we displayed when it was going to terminate, like if they went on vacation, then they could come back and it's like what they were doing was gone. So the solution we came up with is there's now two time periods. There's a time period of when it will stop, but then they can still restart it. But then, and then after it's been stopped, another time period of when it will actually terminate. And those are like, I think I put like 36 hours for the first one. So it's like, it'll basically stop after one working day uh, and when you're not working, right? You're off shift. And then after that, since it's terminated, it's not consuming much resources. So like I think I made it a month after that. So basically that's what this change is. And I wrote like a unit level test for it, which is this one. Um, so you can see here, it's basically I'm using the RSpec parameterized table syntax for the core of the business logic here. Um, I'll put this over here. Let's just close everything. So like this is basically the core of the business logic we're talking about. There's this one step, which, this lives in the ROP chain here, Workspaces Lifecycle Manager. This is the reconcile ROP chain of when we manage the state of the resources. So that's the big picture here. The logic that we're testing is pretty simple here. So like this step gets the context, which is like basically just the workspaces in their current states is what we care about out of it. And so like all of the workspaces the agent knows about that it's sent over in the reconcile loop, we're we got a hand up, Safwan.
Sorry, Chad, I just wanted to ask, like the manager is a new step in the chain, right?
Hmm?
The manager is a new step in the chain.
Yes, I'm adding that as part of this epic and then
Okay,
more.
okay. Okay, that's one cool, cool.
Right. So then, this is basically just a bag of data that represents the all of the workspaces that the agent knows about. And this whole point of this chain is to like manage their state, start them, stop them, whatever, based on rules, whatever the user has done. And this particular one is like introducing these rules about when they should stop and when they should terminate. And so basically you just loop over them all. If they're already terminated, we do nothing. Like they're already gone. Otherwise, like if it exceeded the max hours. So like a third thing I didn't mention was like there's a year hard limit because that's how long the personal access tokens last. Like the maximum you can make a personal access token is for 1 year in GitLab itself, and that's what we use for authentication for the workspaces themselves through the proxy. So like nothing can be more than a year. So this is the first check. And then the second one is what I said, like if it's been running over a certain period of time, by default 36 hours, but they can configure it to be longer, then it will stop. And then this one is the maximum hours it can be stopped before it's finally terminated, which I said, I think I made that a month by default. So that's the business logic here. And those are just the three methods here that have the simple logic.
I
So
have a tangential question. But now, are we allowing the user to set the termination hours for all workspaces, or is still a setting that is set by workspace?
no, these are all at the agent level. So like all of which the agent is tied to is installed on the cluster, and it's like a monolith side concept. So for all of the workspaces that the agent is owns,
Sounds good.
let's run on that cluster, have these two same settings.
I guess to follow up the question to ask, like that means completely we're moving away from workspace level settings. Like for example, you know how you get the dialog box when you want to create a workspace and you add like information? That's completely gone now. And we only rely on agent level settings for any workspace we spin up. Is that correct?
I'm not sure we're doing that in every case, but like for sure this one where they used to be able to control it, the termination on a workspace level. Yeah, this one is going away, and it's just because it's less. We may want to let them do that, but for now we're going to see if the agent level settings are okay, because it's like less of they're going to lose data. Like they're not going to, they'll lose any in-memory data when we kill it, but they're not going to lose any data on disk and the attached volumes to their workspace for a month, right? So that should like cover anything but a really long vacation, right? If they come back, they're not going to say my data is gone. So that's why, the thinking I think is we don't need a user level control for this. And the feedback, Marcel, the director of UX, who is still our de facto designer until we get a new one, his direction is like very strongly like remove things from the UI, minimize complexity until we have actual validated user feedback that we need this. So yeah, we're removing the workspace level setting. Does that answer your question?
Yeah, that makes me happy.
Yeah, it makes things simpler. Like it makes it a lot easier to reason about when everything's at the agent level. This stuff is hard to reason about anyway. Okay, so testing levels. This is in our docs. It's under the development testing. Where are we at here? We're under the main doc site, contribute to GitLab, development processes, testing standards and styles, testing levels, which does not match the URL structure, unfortunately, but whatever. That's the docs team. But I know we've talked to testing pyramid, right, Safwan? And you familiar with this, Daniel? The testing pyramid?
No, not really.
Okay. That's cool. Did you happen to update the doc, Enrique?
Yes, I did.
I'll try to drop some of these notes in there after the fact.
I'm gonna also paste let me create just a section for today's pairing session.
Yeah, great. And I can put some of these in. So this is an article that I like that I always share people on. This is the Martin Fowler's article on the testing pyramid. And basically it's at the bottom of the pyramid are the very cohesive decoupled isolated tests for like a single unit. So like a single class and its tests, right? And not, and at the very bottom, like you mock all of your collaborators, right? You're not involving multiple classes. You're mocking everything that's injected or used or referenced by it, and you're only testing the business logic only in that class. And then as you go further up the pyramid, then what exactly they are depends on the language. It depends on the ecosystem and the frameworks you're using. But at the top is like you're closer to the actual user interface. So at the very top of the pyramid is testing things exactly as a user would. So in a case of a web UI, it's like actually using a tool like, Capybara or Cypress that's simulating clicks on the UI. Or for an HTTP API, like you're actually doing real HTTP requests with curl or postman or whatever testing automation framework. Or for a CLI, like you're actually manipulating the standard in, standard out, and standard error to simulate the interaction of a user with that UI. So whatever the external user interface is of your application, like directly interacting with that is at the top of the pyramid. And then in between is like everything in between that is like, okay, maybe I'm testing in the middle here, like some subsystem of my application, that's like, it involves a lot of classes, but it's not involving the UI, or, it's testing all of the, the Rails backend logic, but it's not actually involving any of the browser logic, right? Or maybe it's involving a little of the browser logic, but in a way where some stuff is still simulated. It's not actually a completely separate browser instance, right? And we have examples of all of those. And so like here's our version of that in GitLab itself, end to end, which are basically the ones that QA mostly owns and manages, the feature tests, and then there's also request specs. Like even these are not exactly how they really work. Integration tests, honestly, like here they talk about some of the different ones. Do they have requests in here? Yeah, like spec requests, that these are considered integration level, spec request API. So we have some at these level. So yeah, this is good to read through. For the workspaces feature specifically, we have, in our README, which lives at the root of our domain code, which is, EE-lib remote development, soon to be workspaces when I get around to renaming it. And this is a section we put in the README to say what we use. So I generally follow the standard one, like the two articles I just showed you, the one in GitLab and the Fowler one. And for front-end testing, we follow the standards closely. Like this doesn't even cover that because there's pretty good standards there. But for the backend full stack code, and especially given that we use the railway-oriented programming pattern, it's a little bit different. So like unit tests, lowest level. Like not quite unit tests. These are still pretty low level. They're called request specs. Directly testing the GraphQL API, which is integration in that it's involving some Finder and authorization code. It's testing. It's in the middle of the pyramid. These ones, very bottom of the pyramid. And like, since we have the strict architectural layers here, right? In the workspaces domain, right? We have the Rails monolith, we have the controllers, we have the API layer, we have the service layer, which is really thin, almost non-existent. Normally, this is where a lot of the code lives, but we use the ROP patterns. So we have very cohesive and decoupled stuff living in the middle here. So that's why ours is a little bit different testing levels.
Why do you say that it is not quite a unit test if we are testing a domain layer that has most of the business logic? Do you mean then that we have to pass third-party concerns like database concerns and things like that?
No, because it's not testing a single cohesive class and just that logic only in the class. Because when you do these requests, they're not testing just the resolver. They're also testing the resolver calling the finder, which is accessing the database. They're testing the authorization policy code, which is using the declarative policy, third-party framework, and all of that. It's not just a strict unit test of only the code that lives in a single class. Whereas, if you jump to this one here, like the way I have mocked things out, I've mocked everything. I'm passing in, a mock context, which contains mocked workspace fixtures, and every interaction with it is mocked. And this has no interaction with any other class outside of it, other than like this, the past calculation, which is like active, a really core like active record utility library, right? Just how do I do time? But that's literally the only thing outside of this class that is accessing. So this is much closer to a strict unit test. It's literally only testing the code here and like one core library about time handling. So does that make sense? The difference?
Yeah, it does.
The GraphQL tests aren't not quite a unit test because they're testing this other stuff. So like going up the ROP main level integration test. So we have that option here too. So if you look at this main class here, the main class for the reconcile part of the workspace operations. You can see that it has, each of these main ones have their own test, which is actually not even really testing any of the logic in this. It's just saying, is all of this wired up together correctly? Everything in here, is it in the order, the and then, and the map, the pattern matching? So this is actually like kind of closer to a unit test than the other one, because it's really just testing all of this and our ROP helper methods that we import here.
Can you show again how do you test the order?
We've abstract Ceph1 did most of that when we made a lot of helpers to make it really easy. So basically you just declare this array of all of the things and then the methods that you expect to call, and then you call this RSpec custom matcher, which is expected to invoke ROP steps and handle the context correctly. And then the individual case, nice. It's like this is again uses table syntax, RSpec parameterized. I don't see why I think it gets included somewhere else automatically, the RSpec parameterized. But these are the exact same thing we're doing over here, like a table test for different scenarios. Does that answer your questions?
Yes, that's very cool matcher. I heard that you were talking about how you were in a presentation implementing this matcher, but I didn't know it in detail. But it's very cool to see those abstractions. It's so easy to test the order.
Yeah, it was Paul that pushed for it and Ceph1 that did most of the hard work implementing it. So thank them.
And tried taking me back multiple times for us to get a better iteration.
So then going higher up the pyramid, there's the request integration test. And this is one of the spec requests, remote development, integration. And these, the ones that say requests, like that's actually using like the internal Rails test frameworks, like fake HTTP interaction. It's not a real HTTP, but it's like at a really low level of the stack in Rails that you're interacting with it, like it's actually doing real requests and responses. So this one looks like oh man. Mine always lags when I'm on Zoom. I don't know why. This one. So you can see this one is like, it's getting closer to the user interaction. Like this is at the GraphQL API level that we're simulating it. Still no browser involved here, but we're simulating the actual query like the view component would send. And then we're like going through all of these steps. With a single, there's only a single example in here, right? If we collapse this, there's only a single happy path example because that's the purpose of this test. We're not testing edge cases. This is like, can we go through all of the main business logic, the important business logic, the money path, the happy path, and guarantee that it works. And what this does is just have different steps. So like make the mapping via the API, the mapping for the authorization of the database, simulate the first poll, so simulate the reconcile, and then simulate the second poll. So these are just like simulating the different requests that are happening in the reconcile loop and doing the assertions to say, okay, what is going on and does it look exactly like we expect in the request and response for this reconcile loop. So all of that is getting us to like, I have low-level unit coverage here of this, but this timeout behavior, like to me, reaches the level of like, this is like fundamental behavior that we want to have some coverage, at least at the middle of the pyramid, right? So that's why I'm like, yeah, I think, oops, where was I? This one, right? Yeah. To add some coverage in here for it. And I think it's going to be kind of tricky. I don't think we're going to get that in this current session. That's why I'm sort of just turning this into an overview of the testing levels and talking about it. But going through the higher levels, there's the feature integration tests, right? So spec features remote development. And if you look, like you see how this one includes this remote development integration spec helpers. Like these are the implementations of those different steps, like the expectations and all of the stuff that we're expecting to do through this prototypical scenario of multiple requests in the reconcile flow. But if you look where this is used elsewhere, you can see it's also used at this level in the requests, which is this, no, I went to the wrong one. Back, sorry. Got it mixed up. The requests are lower level, the features are the higher level. I have it right here, features, yeah, that one. So this one, it uses these same helpers in terms of the expectations that it does, because it's the exact same scenario. But this, they exercise the web UI, whereas in the request one, there's no web UI involved. So a little more thorough, because you see here, we're using the capybara interaction. We're actually clicking links, but this is still not a full top of the pyramid like the QA ones here, which are a completely separate browser instance. This is sort of everything running in the same instance, which means you have direct control over the database state in the specs. Whereas in these, you don't. You have to interact with everything through the API. So same scenario, but this is interacting with the capybara to drive the browser, but all in the same testing process.
So then what these testing utilities abstract is the connection to the Kubernetes cluster, or
Oh, not even yet. Yeah.
okay.
So that's the part that this is not yet doing. This is still, because you see here in the helpers, this is still mocking out the like setting up the like enable the agent for group. Like it's doing the same things that it's doing, but via the web UI. But we're still mocking out at the HTTP level the communication between Rails and the request. So in the real world, like the agent is running over on some Kubernetes cluster, the agent is the Go executable. It is calling back to CAS, which is the listening endpoint of GitLab agent for Kubernetes in the monolith. CAS listens to that, and it sort of internally proxies the request to an internal REST API, which is then when it hits the stack here, where it comes, through the GraphQL API, through our thin service layer, and then hits this. And basically, the context that we're getting passed in here is like all of that information that got passed from the agent through CAS, through the internal call, through the controller, GraphQL service down to here.
Yeah, well, my question is if the the testing utilities that we are using both in feature specs and in the integration specs, which part is abstracting the test from? Like which part of the entire system are we mocking with those utilities?
Yeah, it is. If we look at the architecture docs, they've moved those.
Because from the high level, it looks like mostly the Kubernetes stuff, everything that has to do
Yeah,
with
like basically, I don't want to look for the doc now, but it's that interaction between the agent and the monolith that we're mocking out, and you can see those in the integration
the
spec.
two endpoints mostly.
Huh?
I think there are like two endpoints because it's like something called reconcile.
Well, there's the only one, like you can see here, because this includes like cluster agents query, right? And then there's another in the
But this is
integration
to
like helper.
our like the cluster agents query. Isn't that to like the Rails database backend?
Yeah, so let's look at this one, for example, simulate the first poll. So this is where we are simulating the agent's poll. And so what's happening here is we got some data passed in and then a block to do after it. That's sort of lets us handle the difference between the feature level and the request level that does the UI or not. But there's this helper, simulate agent K reconcile post. So wait, no, the yield response JSON.fetch. Yeah, you're getting me forgetting how this works, even though I wired it up. Let's go from the beginning of the spec, right? So starting at the only example that lives here, the it, right? So the very beginning of this, create the mapping via the GraphQL API, fetch the agent config via the GraphQL API, do the initial workspace creation via the GraphQL API, and then simulate the first poll from the agent K. Okay. So like that block that we were passing to that's where we're actually simulating the post, right? Because that looks a little bit different in the feature level that's doing through the web UI and this request level where it's like the fake no UI and the fake one. I forget exactly what the difference is, but going into this helper, here you can see this is the one that's used to always simulate that communication. Did you find the blueprints offline? You can,
Or the CAS?
it's like the
I think it's in the agents
no,
oh,
our architectural blueprint.
I'll search for that.
Yeah. I'm gonna stop my share real quick. Wait for something. Go to the okay, it's I have it back here. All right. So in our bookmarks of, or sorry, in the bookmarks of the Workspaces channel,
I think I
right?
just sent it in the chat. Not sure if it's
Yeah, I got it here.
what you're looking
So the
for.
architecture design document. So in the Workspaces Slack channel, the architecture and the docs and the bookmarks, there's the architecture design document. And this is what I was looking for. They moved it to a different repo. That's why, like, I knew it wasn't in the docs site, and so I wasn't sure where to search for it. But the diagram here, system design, communication between Rails and the agent, right? So like this is the level at which we're mocking it, right? Here's the GitLab monolith, here's CAS, and and here's Rails, which is all the logic we're looking at. Here's the Kubernetes cluster with the agent running on it, and this is the polling loop. Boom, boom, boom. So it's like basically right at this level that we're, or yeah, right at this level that we're mocking out the HTTP interaction. Like, what does that look like? So here we're getting an actual token, right? A valid token. We're setting up the request headers. We're setting up params, like everything we need for a real request, setting up the URL. So those are the 4 things you need for a normal request. Authn, headers, params, and the URL. And then we're doing a post. So this post here is like simulating this request coming from the agent. And what is that post? That because we've included or actually is it, how smart is it? Like it's something that we've included. It's a HTTP mocking framework. Nothing included would be here, but is it actually in the helpers? I don't know. Anyway, it's like an HTTP simulation framework. I forget actually where I included it. Somewhere included. Taking HTTP interactions. So there's that. And going further up. So let's just finish out talking about the testing levels. So that was like almost at the top of the pyramid. That's like testing everything except the actual running Kubernetes cluster, which is really hard to test because all of you that have tried to set it up, there's like a lot involved. And that's why the actual top of the pyramid here, the end-to-end ones, that's why, Jay and the Vita are like constantly struggling just to keep this thing running because it's like all of that infrastructure has to be running and reliable like all the time. And that's also why they only run on master. This level of the pyramid that we're about to talk about, the final end-to-end test, do not run for merge requests. That's really important to understand. And that's why we're so strict about wanting to backfill some level of integration coverage here because we do not, if we break something here that the unit test didn't catch, we're not going to find out about it till it hits master because the Kubernetes cluster they have running is just one, which is like on staging and it uses the staging environment. So only one thing can run it against the one at a time. You can't run parallel tests. Just like in Rails, you can't run 2 tests that use the database at the same time because you get deadlocks in the database. It's like a single infrastructure that's used. That's why our end-to-end test only runs on master after something has been merged. So to drive the point home, that's why it's really important that we have coverage at all of these other levels below this for this particular feature, because we have no QA safety net like almost everything else in GitLab because of the infrastructure concerns. Does that all make sense?
I have a question.
Sure.
So recently found out that E2 test like about a few weeks now. Is there any reason why there's like a limitation in the resources we can provide for like the Kubernetes testing against actual Kubernetes cluster? Is there any specific?
Well, we have the one set up for staging, but there's only one of them.
can we like spin up more dynamically? Is it really that expensive that we can't
Oh,
can
it's
get
not
that?
expensive. It's the make like how many do you need? Like that's a huge amount of automation. Like that's expert level site reliability engineer to keep all that running and completely automated. It's like we just haven't done it yet. If you want to make that your mission in life, that would be amazing. But it is a very, very not easy at all thing to
I guess the
set up
one thing,
or to maintain.
yeah, was the one thing I could say about that is like there's something I used before. This is a quick tangent. It's called test containers. It's like a whole like a library where it gives you an API that you can kind of spin up Docker containers and dynamically write your
Yeah,
test and do that. Yeah.
kind of like Workspaces itself.
Yeah,
So,
exactly. But for testing, and
right.
I researched within GitLab, I don't see it being officially used, but I saw a demo by the cast team and the agents team demoing that functionality. But I didn't see any test actually using it. So I'm not sure. There's probably a reason why, but that's something we could look into to like try and make the system more robust on like an integration level.
Yeah, definitely bring up things like everybody can contribute at GitLab, right? And we have collective ownership, but just like having a way to run it, like as soon as we get Docker and workspaces, like we could, theoretically run Kubernetes on a workspace itself, you know, and
That's workspace, your
we've
workspace.
talked about that inception, right? Workspaces containing clusters, containing workspaces, like it's workspaces all the way down. But that's only one part of it, like automating all of that setup. Like we have, when we tell people to set this up, we're like, okay, here's some Helm charts and here's some Terraform stuff, but for your particular environment, like you need to maybe tweak it and make it work. Like it's automating all of that for our GCP environment, and which, you know, uh, engineering productivity is done some with, the one cluster we have, but it's like not fully, reusable, automated other places. QA has done some setting up the cluster just to run the QA tests only on master, but we definitely should have this locked down a lot more automated, and that would be useful for our customers because then we could give that to them, reusable Terraform, you know, curated, maintained Terraform or Ansible or whatever we end up doing. We just don't have that yet. So it wouldn't net, I don't think it would be a cost if we could on demand spin these up as part of it, but like that's just a lot of plumbing, like from CI, like Terraform all the way down. It's just nobody's done yet. It's a lot of work. Does that answer your question?
Yeah.
Yeah, I would love, the end goal would be to just use Workspaces itself to spin up a cluster and do all of this. Like, and when we get Docker and like all the stuff to the proxy and stuff, I think we'll maybe be there. Okay, so that brings us to the final one, the one we've just been talking about, which actually does, this uses, the fundamental difference between this and the other one that uses the UI is like, this is using actual capybara where the server instance you're hitting is running in a separate instance. In the feature ones, the specs and the stack itself are all running in the same instance, the same memory space, same database connection. So you have like that's why we can like set up the fixtures and all of that. It's really easy. With the end-to-end test ones, the ones at the top of the pyramid here, it's a completely separate system. Like it is, it actually, for the workspaces, it actually runs against staging, the single staging environment, right? And the capybara and tests and stack run over on whatever the job runner is in CI, right? Has absolutely no access to that database. Everything's got to be done through the API. So it's like this one is relatively easy, right? Because for the feature spec, this one, because we have direct access to the database. We can just set up whatever fixtures we want. We can assert against anything directly in the database, or we can use the API. But at this level, it's a completely separate instance. But that also means that like, okay, we have, as long as you have the Kubernetes cluster running and the agent is deployed and running in it, and that agent is correctly provisioned and configured and set up in the instance that you're testing against, and everything else is set up correctly, then you can do the full end-to-end test that's actually exercising the whole thing. Which that wasn't even working for like months, and Jay finally got it working, I think, but it's still very error prone. I'll put it that way.
I find that very very interesting. What is the cause of the instability here? Because, well, as you said before, you need a site reliability engineer to keep a staging running. But
There,
where is the unreliability in all the
I
systems?
mean, it's like I was saying to set this up, like Safwan was saying, to like spin them up and tear them down automatically and reliably, like that's a lot of infrastructure, Terraform, DevOps level work. The current QA tests, like Navitha and Jay, like QA is managing it that themselves with some help, from sometimes we have to ask the GitLab agent for Kubernetes team, or they ask us, or we all work together to do it. But why was it broken for months? It's like the Helm version, something got out of date with something, or this thing broke and nobody noticed it. And like they just quarantined the test because it broke and nobody was like, that's their main job. Like there's no SLAs around it. Like keep the infrastructure for workspaces, QA tests running, like not an SLA or an SLO on anybody's radar. So it was like us asking, mainly just me saying, this is broken. The only time these get run is when I run them locally as part of, the smoke test suite, or anybody else happens to run the smoke test suite, which is why I recommend people to run the smoke test suite locally, because it does run this one as long as you have your local dev environment Kubernetes set up. So that at least gives us some coverage outside of master of that. But again, it's not on CI. So it's just reliant on us, because then we're doing the heavy work of keeping our local development environments able to run it, right?
You mentioned the smoke test. You meant the end-to-end test, right? Not the smoke one.
No,
one.
The smoke test suite.
The smoke also tests like actual CAS functionality. It's not
Okay, like I made this post on the channel a couple of months back. This is a really important thing to know about. Where's the README here? This. Actually, this line. So actually, this should be expanded. It's like, and bold yelling case, and know that these do not run on your MR. They will not get run until you get merged unless you run them here. And this is a quick test that runs everything, but just for our domain, right? It runs all the unit tests, basically everything that matches, our remote development namespace and all of our specs. It runs all of them here. And it's just a shell script.
Even the QA E2E tests?
Sorry, you're correct. They're two separate scripts. This one runs everything but the end-to-end because they're really slow and they will fail. So this runs, the smoke test suite basically runs everything up to all of this, right? And the end-to-end one just runs this, which is the top of the pyramid. And so it is good, especially if you've changed something in the UI that you think may have possibly caused a regression, or you want to be safe, to run both of these. but this one is a little slower. Usually I run this one as a pre-commit hook. It takes maybe about 3, 4, 5 minutes, way faster than a pipeline, which can be like up to a half an hour. And I don't have to wait for the feedback for it to know if I broke something. That answer your question?
Yeah, I guess the last thing I'll say, because I don't want to hold this off too long, is, I mean, you mentioned that the E2E test, one of like the blockers on the higher level is like higher level infrastructure, like things you can only configure with Terraform and stuff like that. But I guess we are kind of able to run them locally, even though they are slow. So I guess, I don't know if this is possible yet, but if maybe as one of the things, action items for like remote development, if we could come
You
up
mean
with like a
Workspaces?
POC, yeah, like a POC, not even workspace, like that's farther ahead in the future, as you said, like because workspace isn't necessarily there yet to be able to test itself. But maybe in the meantime, we can come up with a POC that we can actually like spin up infrastructure with scripts and run the E2E test locally and maybe replicate that in the pipeline in a reliable manner. And I think this will
Yeah,
be
I think,
possible.
and if you look at the actual specs that this runs, you see how this one is, there's 2 in this directory, right? So this is under all of the top level of the pyramid, the end-to-end stuff, all lives under this dedicated directory. It's like a whole separate Rails app underneath here that lives under QA. So it's QA specs, features, EE, browser, whatever the scenario is, remote development. And then there's like 2 things that are really similar and they use the same like tests, but one is with prerequisite done. So this one actually does some of the cluster setup, like not all of it, but updating the DNS. This does some of that, but it's specific to the staging environment and GCP and all of that. This one, which is what we run from our end-to-end script that we have in our docs, just assumes that it's running on localhost, like it actually says it here at the top. It makes
Yeah,
these assumptions.
I guess like there's a nice level that we can forget about that higher level infrastructure stuff because
Well,
it's not really our own concern and it's not like our
I'm
own fault. Like if things get broken there, and then below like that level, we can low-key make sure things there are working well. That way we can have like, I mean, it's not good to pass blame to anyone if something else is broken, I guess, but we can have like, okay, our for sure remote development functionality works. If something breaks above there in the higher level that we can't really control, like you talk about the Terraform infrastructure, that's more of like external to us in a way, like
but
the
that's not
fault.
the end goal is that we can execute a full end-to-end test that exercises all of this, that exercises the this whole thing, right?
Yeah.
But the problem is we need to have an infrastructure to be able to do that, regardless of who's responsible of it. It must exist. And currently, QA is responsible for it, but they've only curated one bespoke, semi-manually configured one that runs on staging. So I agree. It would be amazing if like this one, which uses that with prerequisites done. This currently just assumes, hey, you've got a project set up exactly like this with, GitLab shell and an agent called remote dev that has, a mapping to GitLab shell and you're running it at exactly this port. Or if you have your local environment a little bit different, you can override these with environment variables. But basically, this assumes that all the prerequisites, all of this side is set up locally. Now, if you wanted to, start the task of saying, let's move this to be more like the one that actually runs in QA, where we say, okay, our only assumption is you have Rancher Desktop installed, right? And we're going to do everything else for you automatically in Helm. Like that would be amazing if we, improved maybe start with like with local prerequisite or with
Yeah.
with local or Mac OS Rancher Desktop setup, right? And start making a third version of this that would not require everybody's setup and have everything running manually, that it would do it for them. Like that would be an amazing thing. We just haven't, and nobody's
Yeah,
taken the
it
time.
sounds very difficult. Yeah, to I guess get it right. Makes sense. I guess we can just, as we're going forward, probably like, because I know that time when I asked a similar question in the chat, we linked a lot of like setup scripts that we have. We can look like try and maybe take inspiration of all the setup scripts that we have somehow, and in a way lead towards that, if that makes sense.
Yeah, like I absolutely agree. We should dry those up, standardize them. It will help us. It'll help the customers. Like we should get better about that. It's just nobody's ever had the time or prioritized that. So
Yeah,
anyway, we
makes
didn't
sense.
actually look at any of my code, but basically that's the last thing I have to do on this epic, which is, that adds something to this scenario, which is kind of, involves manipulating time, like I've done in the unit test, like saying these moving time forward. Okay, now the time for it to stop has passed. Is it really stopped? But doing this at the middle of the pyramid rather than at the unit test level, like I currently did.
Oh, well, thank you for taking us through this testing journey, chat.
Yeah, make sure you upload this. We'll put this in the README. It's like a great
I,
explanation, I think.
I definitely will. I put in the document the learning resources that you mentioned, and I'm gonna be uploading this. So
It's not
then,
easy stuff. Like you saw me get confused and I was like, wait a minute, where is the HTTP request being done? I don't know. It's like there's a lot. This is a
yes,
complex.
it's easy to forget. I think that mocking that reconciliation logic and mocking the closer agent HTTP calls is very complex. So
But the cool thing about that, like the one that the request level one, like for me, that's the sweet spot because it's not doing the web UI. So it's like there's no web UI flakiness or, race conditions that happen because whatever the drop down didn't open or whatever. Like it's strict API stuff. So it's like testing all the backend logic, but really thoroughly. So it's like a very thorough happy path test of the backend, and it runs fast. So for me, like whenever I want to test new important backend logic, like that's the sweet spot to add it. And then because I've abstracted it, you sort of get it for free on the web, just by putting the corresponding calls that would do the same thing. But when I'm iterating on it, I can use the fast one, which runs in like, you know, 10 seconds as opposed to the one that manipulates the web browser is like
yeah, it's full HTTP.
long time.
And we can focus those feature specs on happy path. That's something that with the integration test we can actually like test more edge
Right.
cases and it's more through.
And so over time, and to bring it all home, that was like the one point I forgot to make, Daniel. That's why it's tested. That's why it's shaped like a pyramid. Bottom level, fast, easy to run, easy to write, very reliable, never flaky, never fail. Top, unreliable, needs infrastructure, needs browser, needs subject to all of the weird race conditions and flakiness and unreliability can happen there. So you have fewer of them because you want to minimize that pain. And that's why you only have like happy path at the very top, and all of your edge cases, you have a lot more of them at the bottom level. That's why it's wider, the pyramid.
Understood. Thanks for sharing, Chad. This was very informative for me.
Sure.
Awesome. Thank you, Chad. So I'm
Thank
gonna
you.
stop the recording now. Bye bye, everyone.
Bye.
Bye.
Bye.